Problem 4-96. Solve the system of equations at right. We have x plus 3y equals 16, and x minus 2y equals 31. Let's go ahead and solve that first. We have x plus 3y equals 16. We have x minus 2y equals 31.
Meow.
So, as we look at this, we could solve this either by using substitution or elimination. You already know I'm a big fan of elimination, so that's what I'm going to do. I know some of you like to do the subtraction with the elimination. I'm a only addition kind of guy, so I'm going to change one of my equations. I'm going to multiply this one, both sides, times a -1. Just that way I'll have additive inverses for when I solve it using the elimination step. So I have x plus 3y still on the top equals 16. -1 times x gives me that negative x. -1 times -2y gives me plus 2y. And then 31 times -1 gives me -31. So I'm just using elimination there. Actually, maybe I'll, in case your sound's messed up, maybe that'll help somebody with knowing what's going on. So when we do this, we have additive inverses. So those are going to cancel. X plus -x is 0. 3y plus 2y is 5y. And then 16 plus -31 is going to be -15. So 5 times some number gives us -15. We know that number has to be -3. Now to find the x coordinate, let's take the -3 and let's plug it back in for our y. So we're going to say x plus 3 times -3 equals 16. Which means x plus a -9 equals 16. If we add 9 to each side, we're going to get that x equals 25. So our solution to the system here, what we're looking at here, is the point 25, -3. That is our solution to the system of equations.
Meow.
So, we're looking now at letter A. It says rewrite the system and replace x with x squared. So we're going to take our x plus 3y equals 16, and we're going to replace the x with an x squared. So our expression here we should have is going to be x squared plus 3y equals 16. And we're going to do the same thing in the second one. We're going to have x squared minus 2y equals 31.
Meow.
So we want to solve this now. They're asking us to solve it. So once again, you can do whatever method you want to do. We have x squared. I'm going to rewrite it here. Probably should just written it down here to start, but you know this is the answer for part A. So x squared minus 2y equals 31. Now it's your choice whichever way you would like to solve it. I am going to do, I could do elimination again. We could also do substitution. Since we did elimination on the left side here, maybe I'll do substitution on this one. Let's see here. If I know that I have x squared plus 3y equals 16, and I have x squared minus 2y equals 31, if I isolate my x squareds in each of these, I would have x squared equals 16 minus 3y. I just subtracted my 3y from each side. Over here, to get x squared by itself, I'd add 2y to each side, so I'd have x squared equals 31 plus 2y. So let's take these now that we know that these each equal x squared. We have x squared, we have x squared, which means then that each of these has to be equal to each other. Let's set them equal and solve it here. So we have 16 minus 3y,
Meow.
and we have 31 plus 2y on the right side. Add my 3y to each side there. I'm going to have 5y. I've got 16 equals 31 plus 5y. Subtract our 31 from each side. And we get negative 15 equals 5y. We solve that, we get y equals negative 3. So far, we had a negative 3 on the other side as well. But let's take that negative 3 and let's plug it back in. So we want to plug it back into one of our two original equations here that we're started with. Let's do, it doesn't matter to me, let's do this one here, the x squared plus 3y equals 16. So I'm going to do this in red so it stands out a little bit. We have x squared plus 3 times negative 3 equals 16. 3 times negative 3 is going to be negative 9, so we have x squared minus 9 equals 16. Let's add our 9, and we end up with x squared is equal to 25. Got to take the square root of each side. And we have the absolute value of x equals 5, so which means that x equals negative 5 or 5. So we end up now with two solutions. We're going to have the point negative 5, negative 3, and we're going to have the point positive 5, negative 3. So it asks us to what effect did it have on to the solution on our system. Well, we went from having one solution point to now having two solution points. If you want to, you can take it, set them up, graph these, and you'll see that the intersection points are negative 5, negative 3, and 5, negative 3. This one here, they were both linear, so we ended up with one solution there. This is problem 4-96. This is Mr. Boyd. I hope that this helped answer any questions that you have. If not, please make sure you ask your teacher.